Hello guys, in today's grade 12 physical sciences vertical projectile motions exam clinic, we are looking at the Northwest Province's physical sciences paper 1 of September 2024. In fact, 2025. Right. So this question is about 18 marks and we must be done at exactly 18 minutes unless some conditions will prevent us from finishing at this time. By the way, let's thank SA Exam Papers for their library of question papers. Now, let's read the questions. So the question reads as follows. Question 3, let me just write it down. Ball A is thrown vertically upwards from the top edge of a building which is 100 meters high and reaches its maximum height above or its maximum height after 1.5 seconds. Ball A strikes the ground at time t. Okay, cool. An identical ball B is thrown vertically upwards from the same rooftop when ball A is at maximum height. Both balls A and B strike the ground with the same velocity. Interesting. Now, 3.1, oh, by the way, ignore the effects of air friction. 3.1, explain what is meant by a projectile. A projectile is basically an object which is an object upon which the only force acting is the force of gravity. But your definition says it is an object given an initial velocity, all right? An object which has been given, let me squeeze it here, which has been given an initial velocity, which has been given an initial velocity and moves, rather, and then, let me just say that, and then moves under, the influence of gravitational force only. Under the influence of gravitational force only. Okay, this is your definition from DBE. 3.2, using equations of motion only. Okay, using equations of motion only, calculate 3.2.1 maximum height reached by ball A above the ground. Maximum height reached by ball A above the ground. All right. So what I think here, let me begin by saying upwards is positive. So remember, even if you say downwards is positive, it's okay. So let's say upwards is positive. The information we don't have, what is this? We don't have the time, the initial velocity. We only have the time it takes to reach maximum height. We know the final velocity. We also know, what is this? We also know, in fact, that's all that we need. So let's see. The time is 1.5 seconds. And then what else do we need? Let's just say initial velocity is 0. And the reason I'm saying that is that I'm using time symmetry. You can represent your answer like this. I'm using time symmetry. Okay, so from maximum height. Okay, from maximum height. All right, this is all that I need. And I will say delta y equals initial velocity times time plus half a delta t squared. We are looking for this delta y, initial velocity from maximum height to point of return. Okay, point of release rather will be 0 because it's from maximum height. The time is 1.5 seconds. And then Acceleration, because you said upwards is positive, will be negative 9.8. And the time is once again 1.5 seconds. We don't have to waste time. Our displacement will be 4.9, right? 4.9 times 1.5 squared. What do we get? We get negative 11.025, right? Therefore, this is 11.025 meters. However, maximum height above the ground. Okay, so maximum height will be, the height of the building is 100 meters, and from maximum height to return to initial position, it took the object 11.02, or the object travel 11.025, right? 11.025. Therefore, this is 111.03 meters. That's maximum height above the ground, right? Perfect. 3.2.2, the velocity at which ball B hits the ground. We don't have to stress. They said both balls strike the ground with the same velocity. Again, they said the balls are identical. Right. So once again, I will say final velocity of object A equals final velocity of object B. This is all that I need to state. Now I will say once again, upwards is positive. Okay, upwards is positive. Guys, it does not matter if you change the direction you want to use as positive in your different questions. As long as you are consistent, or rather, as long as you know what you are talking about or what you are doing. Okay, so let's see. So what we have here, we are looking for the velocity at which ball B hits the ground. I will say using A from maximum height. Remember, we haven't yet calculated its initial velocity. From maximum height, you can write this statement in your answer sheet. I will say initial velocity here is 0. Final velocity, I do not know. I know the displacement. Then we are good. We will use Vf squared. Nice, eh? Vf squared equals initial velocity squared plus 2a delta y. What is the final velocity? It's what we are looking for. Initial velocity is the velocity at maximum height. It was 0. We said upwards is positive. Acceleration will be negative 9.8. Displacement is basically maximum height above the ground of ball A. So it will be negative 111.03. Okay. So 2 times 9.8 times 111.03. Oh boy. What do we have? Let's see, when we simplify this, Vf squared is 2176, 2176.188. Now Vf will be the square root of this, which is 46.65. 46.65 meters per second. Remember, you are looking for the velocity, right? So this, to strike the ground, is a downward motion. So your answer must be 46.65 meters per second downwards or down. Doesn't matter. All right? It doesn't matter. All right. So now what do we do? Okay, now what do we do? Let's see now. Now we will say, let me see. Now we will say, let me see. Now we will, in fact, we are going to question 3.2.3. The time it takes for both balls to hit the ground. the time it takes for both balls to hit the ground. It seems both balls will take the same time because they are the same, they are identical balls. All right. We have ignored air friction, so they will take the same times. Right. So what I'm gonna do now is this. I do not know. In fact, I can. I can find 3.2.3. I know already that the time taken for ball A to reach maximum height is 1,5. So I will say, once again, upwards is positive. Using A from maximum height, ne? Using A from maximum height to the ground, okay? To the ground will be, once again, I know initial velocity is 0, final velocity we have just calculated it, isn't it? We have, right? Yes, we have. So let's just proceed. And then we don't know the time. So we say final velocity is negative 46,65. Initial velocity is 0. And then the acceleration term, because we said upwards is negative, will be we said upwards is positive. So acceleration will be negative 9.8. So it'll be negative 9.8 delta t. Now, here we have 9.8 delta t equals 46,65. Let's see. 46.65 divided by 9.8, what do we get? What do we get? Okay, hold on. 46.65 divided by 9.8, we get, let's see, delta t equals 4, equals 4,7602, right? Now, total time taken, okay, total time taken, which is t, right, will be, this is what they said to us, will be t equals 1,5 plus 4,7602. Let's see. We get 6,2. We get 6,26, right? We get 6,26 seconds. We are good, right? We are good. Now, 3.3, draw a labeled velocity versus time graphs on the same set of axes for the motion of the two balls from the moment they were thrown until they strike the ground. Indicate the following on the graphs: the velocities with which each ball was thrown, the time at which ball B was thrown, the velocities with which the balls strike the ground, and the time at which ball B strikes the ground. So 3.3, you will realize we don't have the initial velocities. Once again, upwards is positive, right? Upwards is positive, all right? So for ball A, I will say final velocity equals initial velocity plus acceleration delta time, right? So what is this? We have, and this will be the same for both of them. So it'll be, what is the final velocity? Let's take that 46, negative 46,65 equals initial velocity plus A, A is negative 9.8, isn't it? Or what I can do, guys, what I can do is this, from maximum height, okay? From maximum height. okay, from maximum height. So I will say this is 0, and then initial velocity is unknown, minus 9.8, and then the time is 1.5. So 0 equals, and I'm going to write the comment here, from maximum height, or to maximum height rather, to maximum height. All right, to maximum height. So this will then be V 9.8 multiplied by 1.5 will be 14.7. Therefore, initial velocity is 14.7 meters per second upwards. Isn't it? So you then ask yourself a question. Then what would be the initial velocity for thingy? Initial velocity for object B. It will be the same thing, right? It will be the same thing, right? Oh yeah, because we found the time it takes both balls to strike the ground from the moment they were thrown. So this is also initial velocity of object B. Okay, because these balls, by the way, these balls are identical, right? These balls are identical. And not only that, because we have ignored effects of air friction. All right, perfect. Let's go now. All right, let's see. So object A was, this is what? This is velocity, meter per second. Object A was thrown at, right? And this time here is 1.5 seconds. This is object A. And the velocity is negative 46.65. Oops, I don't like what I did. Let me just zoom it here. Negative 46.65. And initially it was 14.7. That was the initial velocity, right? And then object B, it starts here, and then let's say it ends here. So this will be object B because they fall at the same point. This is object B, and they say you must indicate the time at which B was thrown. So here is it. Here is the time at which B was thrown. And we must also indicate the time at which B strikes the ground. So guys, for both objects, their motion takes about 6.2 seconds. But when exactly will this one that was thrown 1.5 seconds later strike the ground? You just say 1.5 plus 6.26, and this will be 7.76. Now, the time value corresponding here will be 7.76. And this axis is the time axis. Okay, this axis is the time axis. All right, let's see if we have left anything. Velocities with which each ball was thrown, correct. The time at which ball B was thrown, yes. The velocities with which the ball strike the ground, yes. And then the time at which ball B strikes the ground, yes. And then we are done, just like that. And that is a wrap. Bye-bye.